done previously and it is not scalable. For example, could be we can integrate for hierarchical and distance-based clustering in the form of two algorithms. The first one is Birch and the second one is Chameleon. And Birch was proposed by Yang et al. And it has an incremental construction of clustering feature tree and a hierarchical data structure for multi-phase clustering. So the first phase scans the DB to build an initial in-memory clustering feature tree, and in the second phase we use an arbitrary clustering algorithm to cluster the leaf nodes. So the advantage is that it scales linearly, but the weakness is that it handles only the numeric data and is sensitive to the order of the record data. So the second one, which is Chameleon, it was proposed in 1999, and it measures the similarity between a dynamic model. So two clusters are merged only if the interconnectivity and closeness or the proximity between the two clusters are high. So they can be in the form of graph-based and which is a two-phase algorithm. First it uses a graph partitioning algorithm, and then it uses an agglomerative hierarchical clustering algorithm which finds the genuine clusters by repeatedly combining the subclusters. Excuse me. Then we have Cannon graphs and interconnectivity, and you can go through several expressions. Okay, so what is relative closeness? It is the closeness between a pair of clusters Ci and Cj, and the absolute closeness between Ci and Cj is normalized with respect to the internal closeness of the two clusters Ci and Cj, and the expression for this is given in the slide. You can see it. So how we merge clusters? Merges can only be done to those pairs of clusters whose R and RC are both, Ri and RC are both above some user specified threshold. So we can specify some thresholds, and if the criteria is followed, if the clusters they follow that criteria of threshold, then we can merge them. So merge those maximizing the function that combine Ri and RC. So this is a grammatical explanation of the Chameleon algorithm. You can go through it, and these are some experimental results. The next topic is about density-based methods. And density means that the number of data elements inside a unit space of a cluster. So clustering based on density, such as density connected points, it has some major features. For example, you can discover clusters of arbitrary shape or any shape. It can handle noise, and only one scan is needed. And we also need density parameters as termination criteria. Several algorithms are there for density based, which are dbScan, Optic, and DenClu, Quick. These are all algorithms which are based on density. And the basic concept of density-based clustering is that we have two parameters. The first one is EPS, which is the maximum radius of the neighborhood, and then we have minimum points, which are the minimum number of points in an EPS neighborhood of that point. So density, directly density reachable is any point P which is density reachable from a point Q with respect to EPS and minimum pair points. If P belongs to n EPS and the core point condition satisfies. Now you can see density reachable and density connected. A point P is density reachable from a point Q with respect to EPS and the minimum P tier points if there is a chain of points P1 through Pn such that P1 is equal to Q, Pn is equal to P, such that the Pi plus 1 is directly density reachable from Pi. The density connected is a point in density connected with respect to point Q, also with respect to EPS and minimum points if there is a point O such that both P and Q are density reachable from O. So you can see the diagram. So here's a graphical representation of the DB-scan algorithm, which relies on density-based notion of the cluster, and it also discovers the cluster of any shape in spatial database with noise. These are some experimental results. Okay, the next algorithm is known as optics, which is a cluster ordering method, and optics means ordering points to identify the cluster. It was proposed in 1999 and produces a special order of the database with respect to density-based clustering structure. And this cluster ordering contains information which is equivalent to the density-based clustering, and it is good for both automatic and interactive clusters and can be represented graphically, or you can also use some visualization techniques to represent it. The next type of method is the grid-based clustering approaches, which are which once became very famous. So grid clustering methods, they use multi-resolution grid data. An example of such methods could be string, click, and wave cluster, which were proposed in late 1990s. So in 1997, Wang et al. They proposed the statistical information grid approach, where the spatial area is divided into some rectangular cells, and there are several levels of cells corresponding to different levels of the resolution. So each cell at a high level can be partitioned into a number of smaller cells in the next lower level, and some statistical information of each cell is calculated, and this can then be stored beforehand and is used to answer some queries. So it uses a top-down approach and start from a pre-selected layer, and for each cell in the current level, so we compute the confidence interval. The next algorithm is, string continues. So string then we remove all the relevant cells from further consideration, and when we finish examining the current layer, we proceed to the next layer and repeat this process until the bottom layer is reached. The advantages are that it is query independent and it runs in a linear time, which is okay, and the disadvantages are that all the cluster boundaries are either horizontal or vertical. So we automatically identify subspaces of a higher dimensional data space that allow better clustering than original space. So click can be considered as both density-based and grid-based. It partitions an n-dimensional data space into non-overlapping rectangular units, and a unit is dense if the fraction of the total data points contained in the unit exceeds the input model parameters. So click partition the data space and find the number of points that lie inside each cell, and it is also used for identifying the clusters and generation of the minimal description for the clusters. And the strength of click is that it automatically finds subspaces of the highest dimensionality, and it is insensitive to order of the records, and it is scalable in terms of linear scalability. The weakness is that the accuracy of the clustering result may be degraded at the expense of simplicity of this method. Okay, so the last topic for this week is about the evaluation of the clustering criteria, and we can measure clustering quality, and there are three kinds of measures: external, internal, and relative measure. External measure is supervised, which means that we employ criteria which is not inherent to the data set, and we compare a clustering against the prior or expert specified knowledge. As opposed, internal clustering is unsupervised, and the criteria derived from the data itself, and we evaluate the goodness of a clustering by considering how well the clusters are separated and how compact the clusters are, and what is the silhouette coefficient. And then the relative clustering algorithm, it is directly compare different clusterings, usually those obtained by different parameter settings of the same algorithm. Then we have some matching based measures, which for example are purity, maximum matching, F measure. We can also have some entropy based measures, for example conditional entropy, normalized mutual information or NMI, and we can also have variation of information. Then we have pairwise measures. For example, we can have true positive, false negative, true negative pairs measures, and Jaccard coefficient, random statistic, Fox-Mello measure. Okay, in terms of correlation measures, we have discretized Huber statistics and normalized discretized Huber static measures. So these are all the measures, and with this we also conclude our this week's topic, which was based on clustering. I will try to upload the slides today or tomorrow inshallah on the Blackboard, and you can go through these slides. Okay, so if you have any questions, please go through the slides and post your questions on the Blackboard area. So do you have any questions?